What we're mostly concerned about here, though, is what happens once the information reaches the retina and forms an image on the retina. And at that point, the photoreceptive cells that line the back of the eye collect the information from the image and funnel it through this single, rather narrow channel, the optic nerve. But one very striking thing that the retina does is something that we're all familiar with in terms of, for example, how a digital camera works or how a video camera works. We take a lot of information and we compress it down so that it will fit conveniently onto our tapes or onto our hard drives. The retina has about 100 million photoreceptor cells in it, which sense the intensity and color of the light at each point in the image. And the information from those 100 million receptors is compressed down so that it comes out of the eye along the optic nerve in about 1 million fibers. So there's about 100-to-1 compression of the information performed by this circuit in the eye, so that what transfers into the brain can be, I think arguably for physical reasons, carried along this optic nerve. One of the things about the eye that is very striking, and a striking aspect of its design, is that its visual resolution, its acuity, is only very good at the very center of gaze, exactly where you're looking. And you can become aware of this yourself if you look carefully at Eric Kandel's face, for example, as I am, and then try to work out the details of what color shirt Pavan Sinha on my left is wearing. You can't do it. And the reason is that your visual acuity falls off as you move away. And that's because your retina is very specialized for detail in the middle, and its sensitivity falls off to the periphery. And as a result, you have to move your eye around. So the way you make up your picture of the world is by moving your eye from place to place and capturing multiple snapshots and assembling them into a percept.
Now, normally, in our normal vision, everything seems so automatic, we don't realize that this is really what's going on all the time. Our eye gives us this light and dark information, but it doesn't come in an organized form. And the problem is light and dark can come from many different sources. It could be a light or dark spot because the fur is got black or white pigment in it, or it could be some shadow that's being cast causing it to be light or dark, or it could be the edge of the dog where the dog stops and the background starts. So this information that you're given at the level of the eye is very ambiguous, and so there's a sort of a detective problem, a problem-solving task that the brain has to deal with, which is how do you piece all these bits of information, each piece being ambiguous, how do you piece it all together into a single coherent story that tells you about what's really in the world. The brain is designed to pull out the information that's stable and important and meaningful, and to throw away the information that's sort of accidental.
Well, one of the things that's key for the visual system's success in doing this is what Ted was talking about earlier, which is its ability to throw away the information that's incidental. So to throw away where the light happens to come from, how the face happens to be posed, where the shadows happen to fall.
Do we know how that happens?
Well, we know from the cylinder on the checkerboard what some of the principles are. We do not know exactly how that happens in detail. If we did, we would have written a computer program to do it, and the computers would be as good as we were.